All right, the last piece of chapter 5 is 5.7b. Last time I didn't do 5.7b because I wanted you to practice that monomial division where you had to break it apart and put the monomial under each individual piece. You guys remember that part? Well, in this section, they no longer look like that. They look like 3x squared minus 5x plus 4. And x plus 2 is what we have for our divisor in this case. This is our dividend, so we're going to put that underneath the radical, or underneath the division symbol. We're going to put the denominator part, or the divisor, out in front. And so the first thing that you want to do is you want to first, let's go back and take a look at what happens in normal
division. So if I have 81 divided by 3, what has to happen? Well, I take 3 and I ask myself, how many times does 3 go into 8? How many times does 3 go into 8? Twice. 2 times 3 is 6. Leaves me, and what did I do at this point? When I had and wrote my 6 under there, did I add 8 and 6 together, or did I subtract them? Subtracted them. And so I need to subtract 6 from 8, giving me 2, bring down my 1. Then 3 goes into 21, 7. 7 times 3 is 21. Subtract again and get my answer of 0 for remainder and 27 for my value method. What's that like that? These? Of course. Okay. So now, what we need to do with this piece is, notice how we looked at the 3 and said, how many times is 3 going to 8? And pay attention to these guys. If you're sitting there working on something else and not paying attention, I can guarantee somewhere down the road this is going to get you. Okay? You're going to wish you had. Okay? Because these are not, if you get the pattern down of what you're doing, they won't be so bad. So this piece, what I'm going to do is I'm only going to look at the x. And I'm only going to look at the very first piece here. And I'm going to ask myself, what do I have to do to x to make it look like a 3x squared? Or in other words, you could take 3x squared, put x underneath, just like we were reducing those monomials, and I would get 3x. That's what I'd have to multiply this x by in order to make it become a 3x squared. Now if you notice, I didn't put the 3x above the 3x squared, I moved it over. Because now the next piece we need to do is we need to take 3x and times it by x, and take 3x and times it by 2. So 3x times x is my 3x squared. My 3x times 2 is a positive 6x. Is that okay with that part? 2 times 3 is 6, and the x comes back. Now, just like we did over here in the normal division, this piece that's here needs to be subtracted. And when I have a subtraction and a negative 1 out in front, what do I have to do to all of these? They all change, right? This becomes negative, this becomes negative. Okay? So now, if I combine them, positive 3x squared minus 3x squared, what happens to them? That's my goal. Make these guys cancel. They gotta go away. Negative 5x and a negative 6x. Negative 11x. Bring down my 4. And then we repeat our pattern again. Look at the first piece. What do I have to do to this first piece to make it look like a negative 11x? Or a negative 11x divided by x still need, the x's would cancel out, so I still need a negative 11. So minus 11 up here. And then repeat my pattern again. So I'm going to take a negative 11 and times it by x and times it by 2. So then what happens? Negative 11 times x is a negative 11x. Negative 11 times 2. Yep. Then, go back. Because I got to subtract it, I'm going to change my signs in here. And then add them together. So a negative 1 times a negative 11 makes the positive 11x. Negative 1 times a negative 22 makes the positive 22. And what am I left with? These guys cancel. Correct? First is that. Positive 4 and a positive 22. Right. And this is a remainder. And that remainder I bring up above here and put it over whatever the divisor happened to have been. So my answer comes out to be a negative, or positive 3x minus 11 plus 26 over x plus 2. Well, we're going to do that, so don't think that's going to happen. Any questions on this so far? Yes? I'm so confused. Well, let's go back and see what we did do to this. I look at only the first variable, okay? And I ask myself, what do I have to do to make that variable, this piece, look like this? So, basically, it's saying that first piece divided by x, I have to multiply it by 3x. Then, 3x times x is 3x squared. 3x times 2 is 6x, positive 6x. Right? Now, because I'm dividing, this has to be subtracted from this. So I have to change my sign. So this goes positive, it's going to become negative, and this goes positive, it becomes negative. These disappear, because if they do not disappear, you did something wrong. Okay? If this part doesn't go away, you did something wrong. Then you add these together, negative 5 and negative 6 is a negative 11, and bring down my 4. Just like over here when I did that, I put my 2, and I brought down my 1 to do my division. Same thing happens here. Okay? So then, what do I have to do to x to make it look like a negative 11x? Divide the 2, the x's cancel, so I'm going to multiply by negative 11. Negative 11 times x is a negative 11x. Negative 11 times 2 is a negative 22. Once again, change the signs in here. So this becomes positive, this becomes positive, the 11x's disappear, the positive 4 and the positive 22 become the positive 26. And so that becomes my remainder and I bring it up above. Okay? So that's what I ended up doing. Now if you want, you can check these. The check will be take the divisor, multiply it by your answer, add in your remainder there. So if you got a remainder, it needs to be added in there. So if I follow this from the other day, x times 3x is 4x squared. X times negative 11 is a negative 11x. 2 times 3x is 6x. 2 times a negative 11 is a negative 22. Plus 26. Go back and combine like things. Negative 11 and a positive 6. What's that equal? Negative 5x. And a negative 22 and a positive 26. Negative plus 4. And if you notice, this is exactly the same as that. So I'm going to do my math correctly. So you can double check these and make sure that you got it right. Okay? Alright, so let's do some more. I'm going to quickly just run. So let's see what else we can find. How about 4c squared minus 2c plus 4. I don't remember this one either. But we'll put it up here, we got it there, so 2c minus 1. So, same situation, 4c squared minus 2c plus 4 divided by 2c minus 1. So, again, look at, yep, from 2c. How do I get 4c squared from 2c? Yes. Yep, I need 2c. Multiply it by each piece. 2c times 2c is 4c squared. 2c times a negative 1 is a negative 2c. Then, just so I know that I've changed my signs, a negative 1 times a positive 4c is a negative 4c. Negative 1 times a negative 2c is a positive 2c. And then add them down. This and this cancel. What happens with a negative 2c and a positive 2c? Cancels, so I get 0 plus 4. And I can't do anything with 2c, won't go before that yet. So that's my remainder. So I put plus 4 over 2c minus 1. And that's my answer. So that one didn't have a double in it, because I happened to pick one that didn't have all the pieces in it. So, yeah. Okay. So, don't need to find the best ones, but x squared minus 2x minus 35 divided by x minus 7. What happens to it? X squared minus 2x minus 35. Just setting it up in the division column. Yeah, just x. Because again, the first term is all I'm looking at and saying what I got to do to it to make it look like the first term in my dividend. So x times x is x squared. X times a negative 7, 7x. Just so I remember that I'm changing signs, I get a negative and a positive. If you want, just get something with a different color, like ink pen or a colored pencil or something that you can put in there to get those to it. So then x squared minus x squared, then negative 2x and a positive 7x. Then the 35. Always in this step, once you figure out what you're multiplying this by in each case, that always has to change. Because this whole piece needs to be subtracted from this. So you're always going to change that. Alright. So now that x and 5x, what has to happen now? What do I have to do to x to make it look like a 5x? What kind of 5? Because it's a positive 5, I put a plus 5 at the back. So then, 5 times each of my pieces in my divisor, 5 times x is 5x. 5 times a negative 7 is a 35. And again, so remember I'm changing signs in there. I'm going to bring in my other color or my extra pencil or my extra pen or whatever I have to make sure that I change my signs. And so then, what happens? 5x minus 5x. Remember? Negative 35 and positive 35. Remember? So, my answer I type in the box is this. So if I check it, x minus 7 times x plus 5, I should come back with this if I did on my math right. X times x is x squared. X times 5 is a plus 5x. 7 times x is a negative 7x. Negative 7 times 5 is a negative 35. And 5 minus 7x is negative 2x. And notice it's exactly the same as I have over that. So I know I did it right. Okay. Not as bad as you think it would be. Okay. Still steps. Yeah. Yeah, still steps. With what you do have to do. Then they give you ones that might have 3 things in it, or 4 things, I guess, such as y cubed minus y squared minus 9y plus 9 divided by y squared minus 4y plus 3. So we have this kind of a thing, same principle, but change the pattern. If the pattern doesn't change, even though the pattern gets longer, you still look at the first variable only and ask yourself, what do I got to do to it to make it look like a nice cube? Find that. Now, because this has 3 pieces in it, I'm going to move over 3, because that's what's going to line it up underneath here. Because I need to make a y squared look like a y cubed. 4y cubed divided by y squared. 3 take away 2 leaves me with a y to the first. That's fine. That's fine, that's fine. All these y's in there. That's what it comes out to be. So y times y squared is y cubed. Y times a negative 4y is what? Y times a negative 4y. Yep. And y times 3? Then, don't forget, you got to change every sign. That becomes negative. What's the negative 4y squared become? Yep. And what about the positive 3y? Becomes negative. Then I go straight down. Y cubed and negative y cubed, done. Negative y squared, and there's a run out there, plus a positive 4y squared. Is everyone with me? 3y squared? Yep. A negative 9y and a negative 3y. Nope. Negative 12y. Notice the signs are the same? Okay. So if the signs are the same, you got to keep that same thing. And then bring down the 9. And now I go and do the exact same thing over again. So the pattern is, look at the first term. Look at the first term. What do I have to do to make the y squared become a 3y squared? Right? So then, distribute 3 times y squared plus 3y squared. 3 times a negative 4y is a negative 12y. 3 times a positive 3 is plus 9. Change all my signs. That becomes negative. This negative 12y becomes positive. And the 9 becomes and the 3y squareds cancel. The 12, negative 12 and a positive 12 cancel. Positive 9 and negative 9. Yep. Positive 9 and a negative 9. So what am I really left with? Yes. So my answer is just y plus 3. I check it. What is it? When you have, if you're left down here with a remainder, and that y squared won't go into it, you know you're done. Okay? Because in this case I don't have any left. But in most cases, what will come out here is a solid number. Most cases you're going to have something like a 4. And you know you can never make the y squared into a 4. It won't work. So you know you're done with that part. That. And then if we check this one, we might as well just go through and make sure we did our math correctly. Y times y squared is y cubed. Y times a negative 4y is a negative 4y squared. Y times 3 is plus 3y. 3 times y squared is 3y squared. 3 times negative 4 is a negative 12y. 1 3 times 3 is 9. And so hopefully when I get all that done, it'll match the same. So I get y cubed. Negative 4 and a positive 3. What's that equal? Negative y squared. 3y and a negative 12y. Negative what? 9y. And the plus 9 just comes down. And so then if I compare, this is my original, and this is what I got when I checked it, and sure enough they worked, so I know I did my math correctly. So y plus 3 brings it into the answer. I'm going to move to that. Okay. Yes or no? Another one of those? Okay. Now m cubed minus m squared minus 7m plus 6 divided by m squared minus 3m minus 2. See what you get. You guys work it out. See what you get up. If you get a right answer or not. And when you're doing that, I'm going to put this guy on these up here and work the rest of that without your seeing it. Back in your notes if you forgot what you're doing, because you got your pad in there if I wrote down stuff. Go down and go back and take a look at it. Your remainder on this one is fairly large because there's a piece that hasn't disappeared. correctly. Because you're again looking at n squared, trying to get it as a cube. So you multiply by n, you get n cubed minus 3n squared. N times a negative 2 is a negative 2n. Change all of my signs in there. So it becomes negative, and the middle becomes positive, and the end becomes positive. Compare, the n cubes disappear. The n squareds become 2n squared. The negative 7n and the positive 2n become a negative 5 and bring down by 6. Then look at this very first piece and ask yourself, what do I got to do to m squared to get me that first piece? So I need to multiply it by 2. 2 times m squared is 2n squared. 2 times 3n is negative 6n. 2 times negative 2 is a negative 4. Change the signs again. Minus, plus, plus. Negative, positive 2n squared and negative 2n squared, gone. Negative 5 and a positive 6 is a positive 1. A positive 6 and a positive 4 is a positive 10. Minus 2. This is a minus. No. Because this, I can't make this m. I can't make an m squared become an m. So I'm done. Okay? If I can't make this thing become this, I'm finished. I can't do any more with it. And so that's where that m plus 10 comes out at the top. Yes. If you have, let me see. If you have c cubed plus 1 divided by c plus 1. Do you see a difference between this one and the one up above? Any difference? This looks kind of tiny, doesn't it? It looks like I got a little bitty piece, 2 terms, yeah, it's a binomial, divided by a binomial. But the thing about this one is all variables must be in descending order. Oh, okay. That's fine. You're ready yet? Alright, we'll go back and get one that you're ready for. Okay, we'll do one that you are ready for. How's that sound? How about 12t squared minus 20t plus 2 divided by 6t minus 1. We'll just stick this one in there. We'll have it. Here we get the 2t because 6t and 12t squared make it look like an, and I need to multiply by 2 and a t. And 2t times 6t is 12t squared. 2t times negative 1 is negative 2t. Okay. Change my signs. So the t squareds are gone. A negative 20t and a positive 2t leaves me with a negative 18t. Yep, drop down my 2. And then 6t and look at a negative 18t. There's 3 times. Right? 3 times 6t is negative 18t. Negative 3 times a negative 1 is a positive 3. Change my signs. Negative 18, positive 18t, gone. Positive 2 and a negative 3. Negative 1. Yep. Yes. Regular division, I would have to put my remainder on the top of whatever the divisor was, so I'll do the same thing here. That doesn't change. Okay? What do you think? What's your one? Okay, we'll talk about that one, because that's kind of like this other stuff I was trying to explain earlier. Okay? Yeah, we're gonna go on and explain what we're gonna do with this other one. The other one I had given you was the c cubed plus 1 all over c plus 1. All variables must be in descending order, and if one does not appear, a space holder must be added. Now what more does that mean? Well, I have C3 and I have 1. From C cubed to get down to 1 that has no C, you have C cubed, you have 0C squared because I'm descending these 3, 2, 0C, because that's the first power, plus 1. Now the reason I do that, and put these space holders in there, is because if I don't, and I start dividing by c plus 1, what's going to happen is if I take c cubed plus 1, divide it by c plus 1, what am I going to do to c, just like I've been doing, what am I going to do to c to make it look like a c cubed? And as soon as I do that, I get c squared times c, I get c cubed. C squared times 1, I get a c squared, and I don't know where to put it. Okay? But over here, if I put a space holder in for it, I have somewhere for it to sit. And I'm not looking for where it needs to go. Well, over here, I just kind of kicked it out there and didn't know where to put it. Alright? And it just makes it so you don't know what to bring down. But if I put a space holder, cubed, squared, 1, and none, I have a space for it. Now if I go through and do my rules, between here, this is a cube, and this has no C on it. There's a lot of extra pieces that fit in here that go in between this part. And those extra parts, if I put zeros in front of them, that means they really aren't there, but they can be there for my division. Okay? The variables, I was going to give them to you. You also know what variable to use because it'll tell you. Because in descending order, this means I have C times C times C. This means I have C times C. This means I have 1C. So you're lowering the number of C's you have. This one had 3 C's instead of 2 C's instead of 1 C. Yep, 3, 2, 1. If this was a 4, then it would be 4, 3, 2, 1. Okay? And so you have your descending parts in there. Yep. Because now, if I go through and do this math, c cubed minus c cubed, what's happened to those? They're gone. 0c squared and a negative 1c squared leaves me with a negative c squared. There's a 1 here. 0 minus 1 is 1, negative 1, plus 0c. So now what I got to do to c to make it look like a negative c squared? Yep. Negative c times c is a negative c squared. Negative c times 1 is a negative 1c. And I needed my space holder because otherwise I wouldn't know where to put it. No, it would be a positive because I'm going to change my signs. Okay? So my signs change. So 0 and plus 1 is a 1c plus 1. Yeah. Okay, now what do I got to do to c to make it look like a c? Yep. This does, but 0 plus 1 is 1c. Right here. That down there. Yep, you got to bring down your pieces as you go. 1 times c is c. 1 times 1 is 1. Change my signs. C's are gone. 1's are gone. I get a 0. So my answer comes out to be that. No, because we can't, we can do a few more, but we still gotta start chapter 6 and stuff, but, so let's do another one. I think you're making it more difficult than after that. Charlie, this is yours. Do I have it in descending order? That, look at this. A cube and a 1. Okay? Now, you won't know when you don't have it in descending order because that you're going to practice something that doesn't have a spot. It won't have a location. Because if I looked at m and I want to make an m cubed, what do I need to make an m look like an m cubed? Right? And as soon as I do that, m squared times m is m cubed. But m squared times a negative 1 is a negative m squared, right? And it doesn't have a location in here. Right? No spot for it. So that clues me in that I need to add an m cubed, an m squared, to this problem because I don't have a space for it. When I do this, m squared times m, I get an m cubed. But when I do m squared times 1, I get a negative m squared. It doesn't line up with anything. Okay? So it has a hole. You could put one, but that's what I did over here, is I put my 0 in here. Because now when I do this is a cube. So now when I do this, I get an m cubed and a minus an m squared, and I have a location for it. That's why I got to get them in descending order. This wasn't. There was a 3, a 1. 3, 1, not descending order. It's 3, 2, 1. 3, 2, 1. And so you have to have a space holder in there. Yes. No, it doesn't change it in any way. It just lines it up. Then you need a space. Yeah, then you need a space holder in it. Okay. So now if I change my signs in here, this is going to become negative and that's going to become a plus. So now I have m squared plus 2m. So now what do I got to do to m to make it look like an m squared? M times m is m times a negative 1. M. Change my signs. Every time you do that. Because you gotta subtract. Because division says, I need to take what I have here and subtract it from that. I can't just leave it alone. So I get 3n minus 3. So then what? So now what I gotta do to m to make it look like a 3m. Yep, how to make m become a 3m. Yes. So I put a plus 3. 3 times m is 3m. And 3 times negative 1. Yep. And it gives that. Alright, I'll give you another one. Then you gotta add some stuff in the center of a cubed plus 3 all over a plus 3. I have everything I need. So I can just write a cubed plus 3 and start dividing. What you're saying? Make sense, what you're saying? Plus 0a squared plus a first plus 0a should say plus 3, 2, 1, none. Okay? So they have to be in descending order. Because it's a cube down to a 3 with nothing else. Where you start at. So we needed an a squared, right? To make it an a cubed. A squared times a is a cubed. A squared times 3 is a plus 3a squared. Then what? Plus 0a, then done your next one. And then what do I gotta do to that? Just bring down one at a time. Okay? What are times a by? 3 and a. Negative 3 times a is a negative 3a squared. Negative 3a times 3. Yep. Change my signs. Yes. I know what I need. It's not squared, it's just a. So what would I have to multiply a by to make it a 9a? Yes. 9 times a is 9a. 9 times 3 and 7. Change the sign. And so that's the final answer. Yep. And what has to happen to it? Yep. And that's my answer. Divisor. But this is your dividend. This is your divisor, not your quotient. But, yeah. put it over your divisor. Okay? Alright, you guys got it? Last one, then we are moving on. How about this one? 8c squared minus 6 all over c plus 1. Yes. So we have 8c squared plus 0c minus 6. Yep. And what else? And a C. What would have to happen with that? Well, that's plus C by make it look like a negative 8C. Negative 8 times C. When you do this, they have to match. It's got to be identical to it. So, not do different signs. With the plus sign, don't put the plus sign between them. 8c minus 8 plus 2 over c plus 1. You got it? Everybody got it now? Hopefully? Okay. Good deal.